Hello everyone, this is Koba Sensei from ITeens Lab. In this video, I'll be explaining how to use Unity, which is software for making 3D and 2D games. This is the 7th video in the tutorial series. In the last video, we used something called an if statement to create a program where the ball would turn back halfway. This time, we're going to learn about a new feature called destroy. With this destroy function, you can make objects disappear, like making a ball vanish, and things like that. For example, when you're making a game, you might want an item to disappear when it's picked up, or have a ball shoot out and make the enemy disappear when it hits them. So, this disappearing or vanishing is called destroy. This is a function you'll end up using a lot in your programs, so definitely make sure to learn it. It'll really help you level up. Let's work on improving your game programming skills. For this session, we'll be continuing from the previous file, so if you haven't seen episodes 4, 5, or 6 yet, please start from those. Alright, let's get into the content for episode 7. This time, I'd like to show you how to customize the project we made last time. By the way, first, you'll need to launch Unity Hub, and then, after saving and closing your work, I want to show you how to start again from where you left off last time. In other words, I'll explain how to open the project you saved previously. So, once you launch Unity Hub, it should look something like this. For most of you, you probably only have 1 or 2 projects listed here. The projects you've created in the past are saved here like this. I've made quite a few, so I have a lot listed, but anyway, if you click on the one you made last time. Alright, with this, you can open the unit project you made last time. In my case, it's the one where it moves partway and then turns back, right? It looks something like this. Just a moment. The speed is a bit too fast, so I'll adjust it a little. Alright, so this time, with what we made, the turnaround point, right? Last time, the position for the turnaround point was at z equals 30. We set it up so it would turn back there, but now let's try making it so we can change this turnaround point using a variable. Right now, you can change the speed of the sphere from the inspector. Let's do the same thing for this. Instead of having the turnaround point at z equals 30, let's customize it so you can set it to any value you want from the inspector. Alright, let's open up the script. Okay, I've opened the script. It's just as we wrote it last time. Now, I'd like to customize this part. I'll go ahead and remove the comments for now. Alright, it looks like this. So, here, this part, when the z-coordinate reaches 30, it turns back. This is the part where it turns back. Basically, it sets the speed to a negative value, reversing the direction. Right. So, since this is the section where it turns back at 30, I'd like to change this number, 30, into a public variable. So first, let's create a variable. This time, we'll use the int type. For the variable name, I'll go with something like return point. Yeah, that should work. Return means to turn back, right? So, it's the point where it turns back. So, we'll create a variable like that. Now, what exactly is this int? It's an integer. In the previous videos, we talked about float. Float, as we mentioned, is for decimal numbers. Basically, it means numbers that can have decimals, like 5.5 or 5.3, those are valid. On the other hand, int is for integers. So, we created a variable called speed as a container for decimal numbers. And now, we're making a container for integers called return point. That's what we're doing here. As for speed, we often want numbers like 1.2 or 0.1, those kinds of values. But for this return point, we're dealing with larger numbers, so using an integer should be fine. Okay, so let's move on to return point. I'll write it here, once you've declared a variable yourself. I mentioned earlier that creating a variable is called declaring it, and once you've declared and created a variable like this, Input Assistance will start predicting and suggesting it for you. So, if you type part of the name, you can just press the Enter key to complete it. Alright, with this, the program is now set up so that it will turn back once it reaches the return point. Right now, the return point is set to 0, since we haven't defined its value yet. Yes, that's right. For example, here. It's set to 1, so it hasn't been decided yet. I say it's not defined. So, when it's not defined, the contents are 0. The return point is currently 0. So, when you say return point, it tells you to go back, but in this state, it's not good, so we'll set the return point from the inspector. Okay. So, click on the sphere. And, if you saved it properly, then you can now play around with this return point variable from here. Yes. As I explained in the previous videos, this public here, if you add it, you'll be able to adjust it from the inspector. Okay, so just like last time, let's set it to 30, for example. So, when the z-coordinate reaches 30, it will turn back. That's how it works. Alright, let's try changing it. I'll set it to 10 this time. Let's play it. And, just like this, it turned back right away. Let's watch it one more time. When the z-coordinate, once you're inside, turn back, it looks something like this. So, for example, let's try 100. When it reaches 100, yes, it turns back. There it goes. Yes. Just like this. With this, you can now adjust the turning point from the inspector. Now, this part might not be all that exciting to actually do, but it's important for learning how to handle things. These basics are really important. Unity can be a bit tricky, so make sure to practice and get comfortable with these fundamentals. Now, next, I'd like to try customizing things a bit more. For example, I want to make it so that when this object reaches a certain point, instead of turning back, it disappears. Up until now, we've made it turn back, but now I want to make it so that when it gets to a certain point, it just vanishes. Now, I'd like to write a program for that. So, for practice, let's create a new, different object. I've added another sphere, just like before. If you try to use the same name, though, it won't work, so it'll automatically add "1" at the end of the name. So, I'll just name this one Sphere 2 for now. Alright, now we have 1 and 2. I'll move the second one a bit so it's easier to tell them apart. Like this, I think. Okay, this one is 1 and this one is 2. So, I've made 2 eggs. Alright, so from here, I'd like to create a new script for this Sphere 2 as well. As for Sphere 1, it will move forward and then come back. And as for Sphere 2, I'd like to make a script where this one disappears around here. Since most of the content will be the same, I'm going to copy the script. To copy, you use Ctrl+D. On a Mac, it's Command+D, OK, and now it's appeared as Move 1. I'll double-click this to edit it. Alright, so with Move 1, when you open this script, you'll probably see some kind of red error message. The contents should be the same as what we wrote earlier. Now, if you look at the original Move script, the one we didn't copy, the original one, you'll see that it also has some kind of error showing up. Why does this happen? Well, it's because we made a copy of the script. We copied it and, created this file. So, here's the issue, it's right here. The class name. We created it with the name ClassMove. This one is also ClassMove. That's why you can't give them the same name. Yes. So, this is important. A class refers to this block of code, from here to here. It's what we call a unit or grouping in the program. There's a rule that says you shouldn't reuse the same class name. So, the class move we created first and the new copied move here, if they have the same name, it won't work. Let's change the name of this one. Since it was Sphere 2, let's make this one Move 2 as well. Okay. Now, if you save it, the previous error disappears, and the error in the original Move is also gone. Since the class names are now different, everything is okay. There's an important point here, though. Right now, the file name is set to Move1, but the class name is Move2. So, I'll save it as it is, and now I want to attach this newly created script to Sphere 2. Please watch closely. When I do that, an error like this appears. It's in English, so I'm not exactly sure what it says, but what it's basically telling us is that the file name, right? The file name and the class name. Right now, the file is move1 and the class is move2. If the names are different, it won't work. Or rather, it's telling us that you can't attach it. For the move file, I made sure the file name and the class name were the same. But here, they're different. So, when it's like this, you can't attach it. So, should I change the file name to move as well? Let's try rewriting it. Okay. Now, the file name and the class name are the same. In this state, if you drag and drop it, there you go. Without any errors, I was able to attach this move script to Sphere2. Alright then, let's go ahead and write the move2 script. In this one, we're going to make it so that when it reaches a certain point, it disappears. So, right here. This is the condition for when it reaches a certain point. And here, it's set to move in the opposite direction. This is the command, so delete it here. Okay. Now, here we'll add a new line, destroy GameObject. Alright, this command will make this GameObject disappear. The white GameObject written here refers to the GameObject that this script is attached to. In other words, it's this one. Yes, it means we're going to destroy the Sphere2 GameObject that has this move2 script attached to it. That's what the program does. To put it simply, if you ever want to remove a GameObject, like when a ball hits something and the character dies, or in any other situation where you want to get rid of an object, you just need to write destroy. Just keep this in mind as a simple rule. Alright, now, let's actually take a look. If we try to play it as it is right now, probably, the Sphere2 won't move. Yeah. The reason for that is, yes. It's because we haven't set it up in the inspector yet. Alright, let's try it out. I'll set the speed to 0.2 and the return point to 30. Okay. It looks something like this. Alright, Sphere2 disappeared once it reached that point. Let's watch it one more time. Sphere1 turns back and Sphere2 disappears. That's how it looks. Alright, so finally, let's just finish things up a bit. Right now, it's named return point. There's really no need for anyone to go out of their way to change this name, but since return means to turn back, let's go ahead and change it to destroy point, just in case. So, let's change the name. Now, some of you might be thinking, isn't it fine to just leave the name as it is, since it works anyway? But it can get confusing later on. You might end up wondering, what does return point even mean? It's not actually returning anywhere. So, rather than dealing with that confusion later, it's better to rename variables appropriately as soon as you notice it. Alright, that's all for today's content. Thank you for watching this video. Alright. Great job, everyone! How did you find today's content? We've gradually been increasing the number of public functions, but are you all getting used to it? It really feels great when the code you wrote actually works, doesn't it? And now, with this new destroy function, I think you've all added another skill to your toolkit. Let's keep leveling up at this pace. Next time, we'll be taking a look at a feature called rigid body. See you in the next video. Bye-bye.